Welcome back to my video lesson. Before actually going to the study of the formation of periodic table, let us try to understand how the electrons enter the orbits and orbitals as shown in this diagram Aufbau principle. It is surmised that electrons enter the orbits and orbitals in the increasing order of their energy levels. Here, first electron start the entry, say in 1s, orbit 1, s orbital. From there, it goes to second orbit s. From there, it goes to 2p orbital, and there to 3s orbital, there to 3p, and then 4s, and then to 3d, 4p, 5s, and then to 4d, 5p, 6s. From 6s to it goes to 4f, then to 5d, 6p, 7s, and 7s to it goes to 5f, 6d, 7p, and 8s. That means electrons get filled in this order. So whenever the orbit changes, the period changes. That is, a period stands for an orbit, like period 1 stands for orbit 1. So, based on this Aufbau principle, look at this table. In first period, that is horizontal column, first period contains two elements. That is, electrons enter one after one into s orbital because it has space for two electrons. Then coming to second orbit, that is second period, it has 2 plus 6, 8 elements. And the third orbit, that is third period, has 2 plus 6, again 8 elements. And in fourth orbit, listen carefully, watch carefully, 4s to 3d10 and 4p6. There will be 18 electrons entering and 18 elements. Coming to fifth orbit, that is fifth period, fifth orbit has 5s, 2 electrons enter there, and then you have 4d, that is d has 5 orbitals and each orbital has space for 2 electrons. So 10 electrons can enter to form 10 elements, and then electrons enter into p orbital. P has 3 orbitals and space for 6 electrons. As 6 electrons enter, we get 6 elements. So in total, you have 2 plus 10 plus 6, 18 elements. In the same way, sixth orbit, that is sixth period, has 6s to 4f14. 4f has 7 orbitals and each orbital has space for 2. Therefore, 7 orbitals can take 14 electrons. So 14 elements are formed. 5d has 10 and 6p has 6. In total, we get 32 elements in this orbit, that is in this period. And the seventh one, 7s is 2, 5f14, 6d10, 7p6. In total, you have 32 elements in this period also. Now, note, in the first orbit, S has space for 2 electrons. When 1 electron enter into the orbital, you get 1 element formation. Then second electron enters, giving formation to second element. That means, though s orbital has space for 2 electrons don't enter at the same time. They enter one after the other. In the same way, 2p orbital has space for 6 electrons. But electrons enter first one into each orbitals, then second and filling up 3 suborbitals, then second electron starts entering these 3 orbitals one after the another. Like that, 6 elements form. So, we have to understand that electrons, though there is space for six electrons in p orbital, 6 electrons do not enter at the same time. They enter one by one, one by one, one by one, giving formation of an element. Likewise, in d and f orbitals also. First, each orbital filled with one electron. Then, after filling 5 orbitals in d, next electrons start filling up one by one in 5 orbitals. Then form 10 elements. In the same way, in 5f, 4f and 5f also, you have to understand like that. That's how the electrons fill up, each electron fills up, giving rise to formation of one element, right? Here, in this periodic table, atomic number of the element is given, but not its symbol. Please refer to the table for symbols. When an electron enters the orbit, assume that there is one proton in the nucleus. That is, number of electrons in the orbit is equal to number of protons in the nucleus. Right? Let us first start filling the first orbit, 1s orbital. When first electron enters s orbital, one element H is formed, that is hydrogen is formed. When second electron enters, second element is formed, that is helium is formed. Coming to second orbit again, 2s when filled, third and fourth elements are formed. When 2p is filled with 6 electrons, 6 elements are formed. Note, when the last orbital in the orbit is filled with 2 electrons, then that element becomes stable. Example, when 1s is filled with 2 electrons, we get helium 2, a stable element. In the same way, in the second orbit, when the last orbital in 2p is filled with 2 electrons, we get neon 10, a stable element again. Coming to the second period, when 2s is filled, we get lithium 3, beryllium 4, and when 2p gets filled, we get boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. Neon is a stable element. Coming to the third period, when 3s gets filled, we get 2 elements, namely sodium 11 and magnesium 12. When 3p gets filled, we get 6 elements, that is aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. And argon is a stable element. Coming to the fourth period, when 4s gets filled, we get 2 elements, namely potassium 19 and calcium 20. Now electrons enter 3d orbital, where we have 5 suborbitals and place for 10 electrons. So we get 10 elements. They are 21 with atomic numbers 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Now electrons shift to 4p orbital, where place for 6 electrons is available. So we get 6 elements, that is 31, 32, 33, 34, 35 and krypton 36. Krypton is a stable element. So we have to rearrange the elements in such a way that all s orbital elements come under one group and all p orbital elements also come under one group. It helps us to understand their physical and chemical properties easily. And then the table will look like as shown here. Now you will notice that s orbital elements 1, 2, 3, 4, 11, 12, 19 and 20 form two groups, or that is come under two vertical columns. These two s columns or groups become s block elements. 5th, 6th and 7th s orbital elements also come in this block. P orbital elements also fall under 5 groups, that is 5 vertical columns. These p columns with others following form p block. Now helium 2 is shifted to the last vertical column. There it tops the stable elements group neon 10, argon 18 and krypton 36. Now 21 to 30 10 d orbital elements in 10 columns with other period elements falling in the same groups form d block. Elements formation in 5th, 6th and 7th periods, along with the formation of lanthanides elements and actinide elements, will be dealt with in the next video lesson. Thanks for watching and subscribing to my channel. Your comments are welcome. Prepared by N. Sridharamurthy, Retired Headmaster, Krishnanagar, Kurnool, on 3/9/2025. In order not to make the video lesson exceed 15 minutes, the explanation could not be given elaborately. I expect high school teachers who teach physical sciences will show interest in watching these video lessons, and hence this explanation is sufficient enough to understand. Shifting helium to the last column and shifting of p orbital elements will help students understand the gap between s block and p block